Hello everyone, welcome to SCI-EASE. In this video, I am going to explain the various types of the chemical reaction. In all, there are 4 types of the chemical reaction. The first one is combination reaction. Second is decomposition reaction. Third one is displacement reaction. And fourth one is double displacement reaction. So I will explain all these types of the chemical reaction one by one. First I will tell you the definition and then various examples, various chemical reactions in this video. So first we will take up combination reaction. What do you mean by combination? Combination is the combination of 1 or 2 substances. So in this case, either 2 elements or 2 compounds or 1 element and 1 compound, they combine together and result in the formation of some new substance. This is the combination reaction. So I will take up the examples one by one. So we are discussing this combination reaction. In the first reaction, that is burning of the magnesium ribbon, Mg is the element, O2 is the element, and they will result in the formation of some compound, MgO, ash, that will be formed. Okay, so here the 2 elements, they are combined together and they result in the formation of a compound. Another example, hydrogen plus oxygen, H2 plus O2, both are elements. When they combine together, they result in the formation of water, which is a compound. Okay, so this is the one category of the combination reaction where the 2 elements combine. Now next we will take where the 2 compounds combine. CaO, quicklime, it is the compound. It will combine with water and this will result in the formation of a slaked lime. This reaction I have already told you, during whitewashing this reaction takes place. So here 2 compounds combine and they result in the formation of some other compound. So this is again the combination reaction. Next one is when we pass carbon dioxide through lime water and slaked lime, I have told you that they have same formula, CaOH whole twice. When they will combine together, they will result in the formation of calcium carbonate. Milkiness will be there, which is due to calcium carbonate plus water that is formed. So in combination reaction, this type of the combination reaction, 2 compounds, they are combined together. So this is the second type, second category of the combination reaction. Now come to the third category, where 1 compound and 1 element, they will combine together and they will result in the formation of some other compound like CO plus O2, carbon monoxide plus O2 result in the formation of 2CO2. Okay, equation should be balanced, that you know, and I have written the physical state also. So this is the combination reaction where 1 element and 1 compound, they combine. Another example of this we have already done, very important reaction, sulfur dioxide plus O2, they will combine. Sulfur dioxide is a compound, this is the element, result in the formation of sulfur trioxide. No doubt this reaction takes place in the presence of catalyst V2O5. So this is the third type of the combination reaction. So I think combination reaction must be clear to all of you. In combination reaction, either two elements combine or two compounds combine, or one element and one compound combine together, and they result in the formation of the new substance. Okay. Now come to the second category of the chemical reaction, that is a decomposition reaction. Decomposition reaction is just opposite the combination reaction. Here one substance will be decomposed and this will result in the formation of two or more substances. Okay? We have done this equation time and again. Decomposition of calcium carbonate. It will decompose only in the presence of heat, and this will result in the formation of calcium oxide plus carbon dioxide. Clear? In the same way, I have told you that in the laboratory preparation of oxygen, we use KClO3, that is potassium chlorate. We will heat it, and in the presence of the catalyst MnO2, manganese dioxide, this will result in the formation of KCl plus O2. Balancing is there. So what is this? Here we are supplying heat in order to decompose the substance. So this type of the reaction where heat is used to decompose, they are known as thermal decomposition reaction. Thermal decomposition reaction. Okay? Here we are supplying heat. In some reactions, we pass electricity. We pass electricity through a substance. Like you have done in class 7th, that electrolysis of water. When we pass electricity through water, hydrogen and oxygen, they are formed. So here H2O, we are passing electricity, result in the formation of H2 plus O2. In the same way, when we take this molten sodium chloride should be in the molten state. When we take this and pass electricity, this will result in the formation of sodium plus chlorine gas. So these type of the reaction where electricity is used, they are known as electrolysis. This is electrolysis. Okay. Now, some reactions, they take place in the presence of light. Here we are taking AgCl. When AgCl, bottle of AgCl or AgBr, they are brown in color, so that light cannot pass through it, and they are kept in the dark. Okay? AgCl, when it is exposed to light, what is the reaction? What will be the product? It will be decomposed into Ag and Cl2. Okay? And in the same way, when AgBr is exposed to light, then Ag plus Br2, they are formed. Okay? Such type of the reaction where the decomposition takes place by passing the light, okay, they are known as photochemical reactions. Photochemical reactions. Here, photo means light. So when light is passed or when they are exposed to light, their decomposition will take place and they will result in the formation of Ag plus Cl2 or Ag plus Br2. Now one thing I want to tell you, that decomposition reactions, they occur in our body also. You know about the digestion of the food. We take very complex food, and that complex food, in the presence of enzymes, that will be broken down into simple soluble form. So this is again the decomposition of a complex food into simpler substances. Okay, this is an example that you should know. So these are the two types of the chemical reactions. Reaction is the displacement reaction. Here, one element will displace the other in the reaction. But one thing should be clear to you. There is activity series that you will study in metals and non-metals. So according to that, only the more reactive element can displace the less reactive one. Less reactive element cannot displace the more reactive one. So this thing you must write, only more reactive element can displace the less reactive one. The things will become more clear. We will take the aqueous solution of copper sulfate. Copper sulfate, that is blue in color. It's also known as blue vitriol. So it is blue solution. We will put a zinc rod in it. We will make a cell, okay, zinc rod in it. What you will observe that after some time, the solution will become colorless. Why? Because zinc has displaced copper from copper sulfate solution, and now the solution is of zinc sulfate, which is colorless. Okay? And copper, that will be deposited on the zinc electrode. So this is the displacement of copper by zinc. But here zinc is more reactive than copper. That is why it can displace. Take another example. In the activity series, copper is quite less reactive, but silver is lesser reactive than copper even. So we will take AgNO3 plus copper. What will be the result? Copper will displace Ag from AgNO3 solution, and it will result in the formation of copper nitrate plus Ag that will be deposited on the copper electrode. Okay? So you can take another example also, like if we take copper sulfate plus iron. Iron is more reactive than copper, so it will displace it, and this will result in the formation of FeSO4 plus copper. Now initially this was blue solution, and now it has become green in color, light green in color. Okay? So with the color change, you can judge that some reaction has taken place. Okay? Now I want to clear this thing that only more reactive element can displace the less reactive one. Less reactive element cannot displace the more reactive one. So we will take zinc sulfate plus copper. Can copper displace zinc from zinc sulfate solution? No, not at all. So here no reaction will take place, because copper is less reactive than zinc. So by all these examples, the things have become much more clear to you. You practice more equations, and you will be perfect in doing the displacement reactions. Now next, fourth category is double displacement reaction. Double displacement. Here it was the only one element that was displaced by the other. Here the two, okay, two compounds, they are taken in their aqueous form, okay, by an exchange of ions. Exchange of ions will take place and that will result in some other compounds. Like you take the example AgNO3 we have taken and aqueous NaCl. What will be the result? Na will come here and it will result in the formation of NaNO3, and Ag will come here and it will result in the formation of AgCl. These were aqueous, but here AgCl will settle down. That is, it will form white PPT. It will form PPT, precipitates, and it will settle down. Take some another example, that is barium chloride. Barium chloride and sodium sulfate, they are taken in the aqueous form, okay. When they react, they result in the formation of barium sulfate plus NaCl. Here again, white PPT of barium sulfate, they are formed, and NaCl plus NaCl, that is formed. So here, two compounds, they react by an exchange of ions to form two new compounds in double displacement reaction. So these are the four types of the chemical reaction, that is combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. I have taken so many examples in order to clear each and every type of the reaction. So with this, my topic is finished. I will come with some other topic of this chapter, chemical reactions and equations. Till then, thank you very much.